Download this code from codegive.com, link in the description below. What is a vector database? A vector database is a specialized database optimized for storing, querying, and managing high-dimensional vectors. Vectors are numerical representations of data points, such as images, text, or audio, that capture their semantic meaning. In machine learning and AI, these vectors are often derived from model embeddings, where similar items are represented by similar vector values. Why use a vector database? 1. Efficient similarity search. Traditional databases are not optimized for searching high-dimensional spaces. Vector databases use algorithms like approximate nearest neighbors, and, to efficiently find similar vectors. 2. Scalability. Vector databases can handle large datasets and scale horizontally, making them suitable for applications like recommendation systems, image search, and natural language processing. 3. Flexibility. They can store various data types and support diverse querying capabilities, such as filtering and aggregation. Applications of vector databases. Recommendation systems, example suggesting products based on user behavior. Image and video search, example finding similar images. Natural language processing, example semantic search and chatbots. Basic concepts. 1. Vector representation. Data points are converted into vectors using techniques like Word2Vec, BERT, or image embeddings from convolutional neural networks, CNNs. 2. Distance metrics. Common metrics for measuring similarity between vectors include Euclidean distance, cosine similarity, and Manhattan distance. 3. Indexing. Vector databases often employ various indexing techniques, example HNSW, IVFC, to speed up the search process. Code example, using a vector database with FAIS. FAIS, Facebook AI Similarity Search, is one of the most popular libraries for efficient similarity search and clustering of dense vectors. Below is an example of how to use FAIS to create a simple vector database. Step 1. Install FAIS. You can install FAIS using pip bash pip install FAIS CPU. Step 2. Generate sample vectors. For this example, we will generate random vectors to simulate a dataset. Python. Import numpy as np. Set a random seed for reproducibility. np.random.seed, 42. Generate random vectors, 1000 vectors of 128 dimensions. Number underscore vectors equals 1000. Vector underscore dim equals 128. Data equals np.random.random, number underscore vectors, vector underscore dim, datatype, float 32. Step 3, create a FAIS index. Now, we will create an index and add our vectors to it. Python. Import FAIS. Create a FAIS index. Index equals FAIS.index flat L2, vector underscore dim, L2 distance. Add the vectors to the index. Index.add, data. Print, f total vectors in index, index.ntotal. Step 4, query with a vector. Let's say we want to find the 5 nearest neighbors of a new random vector. Python. Generate a random query vector. Query underscore vector equals np.random.random, 1, vector underscore dim, datatype, float 32. Perform the search. K equals 5 number of nearest neighbors. Distances, indices equals index.search, query underscore vector, K. Print, nearest neighbors, indices, indices. Print, distances, distances. Step 5, interpretation of results. The indices array contains the indices of the nearest vectors from the dataset. The distances array provides the corresponding distances, allowing you to understand how similar the query vector is to the retrieved vectors. Conclusion: vector databases like FAIS provide efficient means of managing and querying high-dimensional vectors. They are crucial for applications involving machine learning, where understanding the relationships between data points is essential. By leveraging a vector database, you can build systems that deliver personalized recommendations, effective search capabilities, and enhanced user interactions in various domains. Further exploration. 1. Explore other libraries. Aside from FAIS, you can also look into Anoi, Milvus, or Pinecone for vector databases. 2. Integration with ML models. Implement a pipeline where data is processed by a machine learning model, converted to vectors, and stored in a vector database for real-time querying. 3. Performance tuning. Study different indexing strategies and parameters to optimize performance based on your specific use case. What is a vector database? A vector database is a specialized type of database designed to store, search, and retrieve data represented as high-dimensional vectors. These vectors are typically generated from unstructured data such as text, images, or audio through techniques like natural language processing, NLP, or computer vision. Vector databases are particularly useful for applications like recommendation systems, finding similar items based on user preferences; semantic search, searching for documents or information based on meaning rather than just keywords; image similarity, finding similar images based on their content. Why use a vector database? 1. High-dimensional data. Traditional databases, like SQL, are not optimized for high-dimensional data, while vector databases are specifically designed for this purpose. 2. Performance. Vector databases often use advanced indexing techniques, like HNSW or Anoi, to perform similarity searches quickly. 3. Scalability. They can handle large volumes of data and perform real-time querying efficiently. How does a vector database work? 1. Data representation. Data is converted into vectors using embeddings, example using models like Word2Vec, BERT for text, or CNNs for images. 2. Indexing. The vector database indexes these vectors for efficient similarity search. 3. Querying. When querying, the input data is converted into a vector, and the database retrieves vectors that are similar based on a distance metric, like cosine similarity or Euclidean distance. Code example. We'll use the FAIS library, a popular library for efficient similarity search and clustering of dense vectors. This example will demonstrate how to create a simple vector database, index vectors, and perform similarity searches. Step 1. Install required libraries. Make sure you have FAIS and NumPy installed. You can install them using pip bash pip install numpy FAIS CPU. Step 2. Generate sample data and create vectors. Python. Import numpy as np. Generate some random vectors, 10 vectors of dimension 128. Number underscore vectors equals 10. Vector underscore dimension equals 128. Data equals np.random.random, number underscore vectors, vector underscore dimension, datatype, float 32. Print, generated data vectors. Print, data. Step 3, create an index and add vectors. Python. Import FAIS. Create a FAIS index. Index equals FAIS.index flat L2, vector underscore dimension, L2 distance. Add vectors to the index. Index.add, data. Print, f total vectors in the index, index.ntotal. Step 4, perform similarity search. Python. Generate a random query vector. Query underscore vector equals np.random.random, 1, vector underscore dimension, datatype, float 32. Search for the 3 nearest neighbors. K equals 3. Distances, indices equals index.search, query underscore vector, K. Print, F query vector, query underscore vector. Print, indices of nearest neighbors, indices. Print, distances to nearest neighbors, distances. Explanation of the code. 1. Generating data vectors, we create random vectors to simulate our data. In a real-world scenario, these would be embeddings derived from actual data. 2. Creating an index, we create a face index using index flat L2, which uses L2 distance to compute similarities. You can choose different indexing methods for larger data sets. 3. Adding vectors, we add our generated vectors to the index. 4. Querying, we create a random query vector and search for the 3 nearest neighbors in the index. The output includes both the indices of the nearest vectors and the corresponding distances. Conclusion. Vector databases are powerful tools for handling high-dimensional data and performing similarity searches efficiently. They enable applications in machine learning, recommendation systems, and more by leveraging advanced indexing techniques. This example with face illustrates the basic principles of creating and querying a vector database.